Okay. Yeah, pardon me. So then we'll look at how, as a Python developer who uses PyCharm IDE, we will see how the version control system is, linked to it, and how in your projects, how you can bring, using PyCharm, the Git capabilities inside it. Okay, the version control system capabilities. So GitHub, introduction to it, the various concepts like branching, merging, conflict resolution, and automated deployment with GitHub. Then following that, we'll see how in your PyCharm projects, you can bring the Git capabilities. Okay, we'll go into that in the hands-on session. And following that, an introduction to DevOps and CI/CD. These are some of the happening things in terms of large projects, in terms of open source projects. And also we will take a introduction into Sonar Cloud, which is one of the tools for quality of the code. Okay, so which works along with CI/CD. CI/CD standing for continuous integration and continuous deployment and delivery. Okay, so these DevOps and Sonar Cloud are just introductory in nature. Okay, they themselves are very elaborate, but it's more introductory in nature here. Okay, so this is totally new to you, so that's why most of it is introduction. Okay, but you will learn totally new concepts on what's called a version control system. Okay, so let's get started. So we have GitHub, and it's a collaboration, what we are doing. Okay, so what is a version control system? In fact, today there are various software having component items, meaning you will have written a code which is an artifact. Okay, what we call that is it's simply one program inside a file, correct? So that is called an artifact. Okay, so at the lowermost element, it's just a Python file, right? You have created files like main.py, app.py. Each of that file is an artifact. Okay, now that code can change. Okay, it has an initial version when you wrote it first time. So typically it's written, it is code reviewed for quality by another developer and in your team, and then he has some review changes which he thinks it could be a bug or something like that, and then you take that feedback and implement it and make your first initial version. Okay, so that's your initial release. Okay, so for that code, it is the first version. Okay, now later, so that version is typically, let's say, version 1.0, and you have to save it somewhere in a safe place. Okay, much like you have a locker and you put some valuables inside the locker. It could be money, gold, and things like that. Here, for this first version of code, you want to have a similar version control system. A version control system keeps track of the versions of various component items or various artifacts. It could be code, it could be documents, all that. Okay, and overall in a project there are not just you could be having a product which is released as a it could be a loan management system, it could be a student library system or library management system. Any of these, when you release it, that has various features typically. Okay, in a loan, it could be like there is a deposit and there is some loan which is issued to the customer. There's a customer module. So all these features are, you have various features. Each feature one could be built by one team or one developer. Feature two could be taken by another team. So they all work on different features and they collaborate together and release a product. Okay. So these features could be inside one module. Okay. Like a loan management application could have various modules. It could have a gold loan module, or house loan module. Any of these could be, there could be modules and features, modules, submodules and features. Okay, so then the development goes on in those features by separate developers. They all have to collaborate and keep that first. I mean, they have to release a product. So there is a major release and a minor version, major version and a minor version. Okay. So let's say the first version is 1.0. Okay. So that could have sub components, and each feature each feature could have submodule. So there's a module, submodule, and a component. So meaning there could be a loan application inside which there is various types of loan, and then there could be files, individual code components, okay, individual files. So that is typically how in a product development it goes. In terms of a project, again, same approach, okay. So the developer keeps track of the files which he wrote. He is written in his own laptop or desktop, and then he saves it in a local folder. But that has a element of risk where you could have a computer crash and the files are gone, right? So the need for keeping it in a version control system is important. And how to keep track of the version like 1.0, and then he makes some changes, and minor changes could be 1.1, like that, 1.2. So then if they make a major set of features into that particular module, it could go 2.0. So there could be some, manner in which it is released and different timeline. So then all these have to be kept in track in a separate system. You could create folders, but that's simply at your desktop. So then a version control system allows you to, uh, what's called like place a certain set of files. It could be code files, could be documents, into that repository. So we have the concept of a repository. A repository can contain, it's just a location, okay? It's just a safe location where it can contain all set of files. It could be like you're releasing a certain feature. So all the component files with that particular version is kept into a repository. So you create repositories, okay? The repository, what you create, could be local, it could be remote. Okay, so in typical, there are various kinds of projects. Okay, so when you are having a local repository, you are maintaining a sort of much like the locker I mentioned, a source safe. Okay, even Microsoft uses a terminology called source safe. Okay, so that repository is in your machine, but still, while maintaining a repository in your machine local, let's say your uh, laptop or desktop has some blue screen suddenly and it goes off. So then that repository has some risk. So it makes sense to work in a collaborative manner where a project team, the team members are able to collaborate with each other, and there is a common repository externally which allows the same version control features. Okay, so there you have a collaboration tool called GitHub. So the Git is a version control system, and GitHub is a common platform to collaborate. Okay, so it's a collaboration platform, and there you have lots of developers. They could be open source projects going on, several projects. So a team of community of developers are maintaining a certain version, much like Python has versions, or Django has some versions. So Flask, or each of this is software, right? So there are some open source developers having open source projects in the public repository, which is like GitHub. So these open source projects need a common platform to collaborate, which is GitHub. Okay, under GitHub you can have several such projects, and they all have a repository. Okay, so you basically are talking about collaborating within the team. Okay, and there are certain things you can do. We'll look at the detail now. Further down, CI/CD pipelines. So here we are talking about continuous integration. We look at the concept of what is continuous integration and continuous deployment and delivery. Okay, that means the project um, is continuously going between various stages. Okay, design, development, testing, deployment, integration, deployment, and again somebody is having some enhancement on it. So the feature comes back to design. So it's a closed loop cycle like that. Okay, so and we also will see automated testing and releases. So it allows project teams to implement features like automated testing, releases of software, which is like altogether uh, automated. Okay, it's completely automated. So that means the certain activities has a certain workflow approach, and then the testing and releases of software is continuously happening in an automated manner. Okay, so these are the scope of activities. This is the agenda of what we'll cover. Okay, so I just given you some background here. Okay, so we look one after another each of these things. Okay, did you have any questions?
No.
Okay, okay, no problem. So I talked about a repository. Okay, so the repository is typically the term which maintains your component files. All the files of a project are going to be maintained in what's called a repository. A repository can exist local in your desktop, or it can exist remote. Okay, remote in this case is like you are having it in a GitHub uh, platform, uh, which is a community platform until Microsoft accessed and purchased it. Okay, so GitHub has its origin from the open source communities, and it's still a platform where um, open source developers can build software and keep it in a collaborative manner. The teams within the product development can collaborate with each other, and it's allowing you to create a remote repository. So the repository, what you create initially and maintain, is called the master repository. Okay, so we'll look at the specifics there. Okay, and then from the local you could push to the remote. Okay, now why would you do that? I mean, like I said before, um, you can maintain a local repository. the code can be safe in that repository. People cannot access it so easily. Okay, you can access it. Okay, but when you have to keep it in a common location where you collaboratively work, you are keeping it in a safer location, external, because that way your your machine does not have any issues, and then the whole project file just goes away, right? So that's a need to push from local repository to a remote repository. Okay, from local to you're pushing the file, for example, main.py or app.py, whatever you create, the file is pushed to from the local repository to the remote repository. Same way, pull means you're pulling that file from the remote to the local. Okay, so that's what's called push to and pull from the master. Okay, so here are things you do. You create a create a repository. You can create a local you can also create a remote repository. For creating a remote repository in GitHub, you need to have an account. Okay, it's a free account that can be created. Just has a login for your own security, much like an email box. Okay, so it allows you to once you have a login created, once you log in, you can create your repository. Okay, so and there are other features where once you have a certain software or a repository, you can take that and the other developers can, you know, what's called, you can clone that repository, or you yourself can clone that repository from the remote to the local. Okay, so that's a clone means bringing down a version to your local. Okay, so that's cloning to local. And then you can add more files to the local repository or to the remote repository. Commit. Commit means you're saving, because you'll work on a certain file. You might have added a new function, you modified a function, maybe A plus B was initially the way you defined an add function. Later you changed that function to return to A minus B. Some change, I'm saying. Once the change is done, it is sitting on PyCharm here locally. Then you will have to do what's called commit to write it to the local repository. Okay, and from the local you can do a push to the master, and you can the saved file goes to the remote repository. Okay, and similarly you can pull from the master. Okay, so profile will come, it is at a certain version 1.0, you will pull and you can bring that to your local repository and local desktop to modify that file. Okay, so then you are working on that particular file and the version there is still same. Okay, typical terminologies are like push and pull. Generally, the version control system, there are other version control systems in the market as well, like uh, for other programming languages. Typical version control system uses terminologies like check-in, check-out. Okay, here they're calling it push and pull, but definitely check-in means you are writing into that source safe, or writing into that repository, and check out means you're taking it out. Okay, so that's like much like a hotel or a flight, check in and check out. Okay, so you check into a hotel, check out of a hotel. Again, you check into a flight or I mean, you don't check out, you come finish that trip and you disembark the flight. So typical terminologies, when you hear check-in, uh, it is terminology used for version control systems. Okay. Have you checked in the code is a common thing you might ask, or you might have a software configuration manager role in large projects. So there is a separate configuration manager because there are so many features or so many modules getting developed. Maybe it's about 200 plus modules. So it gets very large. So there might have a software configuration manager role who maintains everything. Otherwise, typically the project manager, if it's a project, is in charge of the code being safe and having the proper quality and so on. Okay. Any questions? Is it clear so far?
Yes.
Okay, very good. So here are things you can do. I put it into 3 parts here. There are certain type of things you can do. Okay. So look at what this is. Part 1, or the first type of activity, you could be contributing to an open source. Okay, so that is an important thing. Most of what's open source is a community of developers. Here, if you look at Python, they are a community of Python developers and they're contributing to improve the product. The product is completely open source. That means the source code is not regulated or not, I mean to say, not in a proprietary organization or not in any corporate, the hands of any corporate organization, which call this is our code, this is to be licensed if you have to buy. Okay, so contribute to open source. So Python developers all over the world are contributing to open source development. One good example is Django development. They build a framework. Again, Flask, what you learned is all open source development. Okay, even the Python software is by the Python Software Foundation. All are open source developers. So then, if you see what all you can do, so here is an example. This is a configuration manager. Okay, so to say, in here is a developer. Okay, so the developer builds something and he can contribute, right? So you have concepts like fork. Fork means the project, let's say here is some CRM system, okay, or let's take simply a student library management system. So here is a software configuration manager who is maintaining a repository. That repository is available in a public uh, location like GitHub, okay, GitHub account, and this person is a configuration manager who is maintaining that. And here is a developer, he also seems to have a GitHub account. He wants to contribute. So if he wants to contribute, what he has to do, he has to get that software could be at some version 2.5 or some version number, right? And inside that there are component files. So he needs to bring a copy from that repository to his location. Okay. So I talked about push and pull, but fork means it takes the entire software and creates a local repository here. So the entire code is so to say like a at that point of time he is brought down here. So that's called a fork. Okay, whole software will come down. So and then he'll create his own branches and all that. He might have added a new feature or he might have improved an existing feature to fix some bugs and so on. And then he can, once he is ready, now he has tested the unit and it seems to be convinced he's fixed the bug, things like that. And then he's creating a pull request. Means pull request will send a request to this configuration manager. And then the configuration manager sees from a list of requests that, oh, he has raised a pull request after making modification to the code. Okay, so that can be seen by whoever is to whom this pull request is sent. Both have a GitHub account in this case. Okay, so GitHub login account is there, and the developer has created a pull request that goes into the queue of this configuration manager. Okay, in that queue, this person picks it up and sort of approving it. Okay, merges to the original branch. The original earlier version would have been let's say 1.0. This changed version could be 1.1. So the merge is done. Once the pull request is approved and accepted, the merge is done. Okay, they will do a merge to create with the main branch. Now, second is part two of it is collaborate within a project. Now, this was an individual case, right? There are two members, of course. This is a project case as well. But this more happening in a context of an open source system. He may not even know that person. Okay, but he'll just create a pull request. So people are working collaboratively. Okay, this way in open source. Another scenario could be like you have to collaborate within a project team. Okay, so here within a project team, there are more than one team members, more than one Python developers. And again, the same, here is a initial developer one, you have configuration manager, here is somebody, the support guy who is trying to fix bugs. We have another developer, another team member here. Now, when you collaborate within a team, you could take the original version, which is called the master. The master repository is there. Instead of bringing the whole thing down, he can create a branch. Okay, a branch, of course, it can be the entire thing can be branched. Okay, but that's we will come to the specifics. But a branch is, I mean, like a version goes let's say the version goes 1.0, 1.1, and 1.2 like that. Okay. So a branch, I mean, the main version can be going like that. A branch can happen from, let's say, it can be any version. Okay. Let's say 1.1, at that point of time, this developer branched it. Okay, so then he has a look, he brings that branch called and does some development in it. Okay, so this is a concept called branching. Okay, that means from the main releases, one developer, sorry about that. So from the main master, okay, we'll call it we can call it either master or main. Okay, from the master repository, a branch can be created. When a branch is created, this developer works on that version, that copy of the main. He is not working directly on the main. So it's important to understand it's like a branch of a tree. Okay, the main trunk is there. This is the one branch of it. He could be working on that modules, features, and all that. Feature one could be taken, enhanced by him, all that. But the main itself can be built by other project team members. Main can move from 1.1 to 1.2, 1.3, and so on. So he is still working on 1.1. The main has moved away. Okay. Maybe there is a bug in 1.3. Okay. So then another customer support development support development or customer support development team is identified, oh, there is a bug. Okay, the functional guy has identified a bug, but it's finally come to the support team to fix the bug. So at 1.3, he takes another branch. This developer takes another branch, fixes that minor fix, and just pushes it back. So he sends a pull request, and the merging is done by the configuration manager. And later, this developer has finished and he is enhanced to the newer feature, and then he creates a pull request out here. So if you see, developers can collaboratively work together in a project. Okay, so this is basically called branching to a development, and then you merge to the master. So once each of these folks are finished, they'll merge to the master, and the master is maintained by in this master repository. So is this clear, Sriram? I can't hear you. Is this clear, Sriram?
Yes, 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 it's clear.
Okay, now I can hear. Okay, so this is part 2. Now we look at fork and merge. So here is a visual example. We have a master. This symbol is for branching. So one branch of it is going with, in this case, the octopus here has got some sunglasses. So I've just put in visually to understand that they are building a feature. Okay. Another branch from the master is building another feature. So I put a hat out here. They both can be in individual branches. When they come together, there is a merge. Okay, there's a merge. And this merge is going to create a new master. Okay, how is the new master? So look, both features are there. Both features are there. So while doing so, it can be like there is separate component items, meaning separate files, or there might be some common files also. Okay, so when there are common files, both set of lines of code need to come together, and the configuration manager has to merge together. I mean, you're merging together. The Git version control system will take care of the merge. But when there are, when let's say one developer set the value of some, let's say some parameter to temperature equal to 30 degrees Celsius. The other, if he also set to 25, right? Both of them are working on the same file, and one wants one value, another wants the same to be a different value. So then you get to a situation called merge conflict. Okay, in such case, we have in PyCharm tools to compare the changes. Okay, to visually see where the changes, like finding differences between two files can be complex, right? So that sort of a visual tool is there in PyCharm. Okay, which keeps track of the history, at what timestamp, what are the kind of change, the change will get highlighted and all that. So visually to indicate to the configuration manager that, hey, this is where the change is. And then they will say, okay, one person has put 30, another is 25. Now what do we do? Okay, so then that decision is taken by the software configuration manager or the project manager or whoever is the senior developer who maintains the repository to see one or the other is finally implemented. So he takes the approach, or he or she takes the approach of handling the conflict and resolving the conflict. Okay, we can't have the same parameter point to two different values. If both also have to be done, then the file has to be modified to handle one after another, okay? Or it cannot be, then we have to take a certain decision to maintain one value, okay? So that the tool allows you to identify, manage such conflicts called merge conflicts, okay? Uh, so, so here is in reality what I just mentioned. Open source fork and pull requests. So when it is an open source, even they are not in a common proprietary or common organization. They are community based. One is doing completely. People are doing completely on their own. Okay, they're contributing to open source. So then that happens, like here is the scenario. He is building one feature. This developer too is building another feature, and they are doing all this push. They are committing to local. He is coming to local, and then they are doing a push. And another code is pulling. All this is going on uh, in real time. Okay, so here is another support uh, developer. He is doing some support fixes. He creates a pull request or a PR pull request. Once the pull request is approved, there is a merge. Okay, and at some version, the version is moved to 1.5, whereas this guy wants the latest, so then he'll fork again. Okay, he'll either bring the whole repository, that's called fork, or he can branch out and build some fixes and then push either way. Okay, so this is how open source works, mostly on fork and pull requests and so on. This is open source. This is not within a company. Okay, though this same scenario can happen within an organization. In open source, it's mostly like a disk, they don't work in a connected manner in real time. They work in more like a disconnected manner, right? But still same functionality happens. Okay, next we look at branching. Branching means we have a master repository. The repository has certain files which you don't want to, change right away. Okay, so you want to work on your own version, but you want the entire thing, or you want that specific file to your uh, repository. So then you create what's called branch. So here is main dot, it's one file. It went to a certain version, okay, and the main can take branches, okay. A certain version here could be on bug fix, and they all merge. These two are different versions. Here was a bug fix, and they merge together, and then they are released. So you could have a bug fix branch. You could name a branch any name. Okay. So branching means he takes a copy and he's working on his own local version. Okay, and then later merging. So branching and merging. So here is version 1.0.0, 1.1.0, and 2.0, 2.1. So the master is going in certain versions, some minor feature, then it moved to 1.1. Then there's a major feature, so 1.1, it moved to 2. Another minor feature, 2.1. So the master is going on like that, but the support team was reported with some bugs, and so they took a branch out here, and from here they started fixing bugs, 1, 2 fixes, and then when they release the 1.1.1 became 1.1.0, they're releasing as a minor fix. So the minor fix is going to the third part, 1.1.1. Meanwhile, the major one, the main master is at a different earlier branch, earlier version. Master is at a certain 2.1, more advanced version. They got more another minor feature into it, which is not with this, right? So this team, the support team, creates a pull request, and then the configuration manager is to merge everything to move it to a 2.2. Okay, so this is how it works in reality. Okay, branch from main as feature one branch or bug fix branch or whatever. Okay, so this is how branching and merging works. Okay, is this clear? Okay, so we have gone into, I'll just recap. We looked at how developers could contribute to open source, okay, with some Git features, like we'll see the features for pull and merge and all that. We can collaborate within a team, branching and merging, okay. And there is also, we've seen the concept of merge, resolving merge conflicts, okay, fork and merge conflicts like this. If everything is okay, it will go smooth. But if there are conflicts, it has to be resolved between branches. Okay. And here is an open source fork and pull request in reality, how it looks. We've seen what a master is and how a branching works. Where we've seen branching and merging between multiple versions, like major version, minor fixes, minor support fixes of bug fixes like that. So basically how the master and the branch work. Okay. So these are the concepts of Git. Okay. Git and GitHub. Okay. We'll see that in action. Okay. So are you able to, there is also one more method of going about called automated testing. So say similarly, like when the developer releases something, you have capabilities in Git and GitHub. GitHub, especially capabilities in GitHub to do automated testing. That code can be checked for quality in automated manner. Okay, so that's when you do automated testing and releases. Okay, Git is one more CI/CD product. The CI, continuous integration, continuous deployment, and continuous delivery and deployment is called CI/CD shortly. So GitLab is a CI/CD platform. Okay, so we'll not be going into a detailed one here. But know that automated testing is possible. I will go into some concepts there. Okay. Yeah, here is deployment. We are having some example of deploying a simple Flask app on a public cloud. Okay. So the Flask app will run out of your own cloud likewise. Okay. So are you getting an understanding of what is version control system? What happens in Git version control system, especially like what are the features you can do? You can contribute to open source by various, these translate to some commands, but you can do it on the command prompt also, as well as we'll see how it is made easy with PyCharm. Okay, so you can learn to do branching and merging, okay, so that you have the skills to collaborate within the project, okay. And yeah, we looked at this in terms of features, and this is how it looks in real time. So these are the concepts for Git and GitHub, okay. Now, we will take CI/CD But let me pause here because so what we have done is we just gone over Git and GitHub at a high level. We understood what the concept of branching, merging, what a repository is, and what the concept of conflict resolution is, and so on. We take one simple example with to see how this is in action in PyCharm. Okay, so that's the next step, and then we'll come back to this DevOps, CI/CD, and Sonar. Okay, so we'll park it here. This is a CI/CD concept. Okay, where it is commonly used in DevOps, software application practice. Okay, development practice in. We look at that. We take a pause there. Okay, so let's switch gears into go to PyCharm. First, I'll show it to you. Okay, I'll do like a site tour or a walkthrough. You don't have to do anything. I have done some sample here, and I will walk through what the various screen and concepts are, so that you understand from a PyCharm standpoint. Okay, shall we start, Sriram?
Yes.
Okay, so much like any other project, you can create a project here, a new project. Either you're creating a project from scratch here, okay, which is create new project, or you can create a project from version control system. That means it assumes somewhere there is a repository, and you can point to that repository. It will start readily creating a project, bring that repository here. Okay, now we take the first option, create a project. I have created a project here, and as you must be knowing, every project has a certain location in your local desktop, that where it is residing. And in this case, I have taken like VCS Git Pro 2. Okay, Git Pro 2, Git repository, like that. So when you create the project, I will show it. New project. See, at the creation of the project, if it's a pure Python project, it will allow you, you can do this checkbox, create Git repository, create a welcome script. So what happens, and we point to one location. So what happens, you name that project, and it's located somewhere. And here I named it like Git project 02. Okay. And then it creates that folder structure under VCS. VCS was a folder there on my local. And then it creates a subfolder there. And this create Git, the repository gets created. Okay. And this is your Python interpreter and all that, which is all the same as earlier. Create a welcome script. It just allows me to just readily have a main.python, some print high script. Okay, so it's just the initial script here, which you're seeing. Okay, this is a project navigator, which shows all the project files. This side is a code editor, and here you have the earlier you've seen the terminal, the control panel, or the console, Python console here. The terminal is here, but this icon is Git. Okay, so if we click on this icon, it opens a menu like that. Here. Do you see that? Do you see that, Sriram? Here?
Yes.
Okay. So Git opens and closes here. So there is some tracking which is going on. And here is some trace of this all that. So this is a panel below. Okay. Now your menu on the top has a Git menu here too. On the navigator, you have a Git menu. Okay. So it has various, there are a lot more in version control systems. So here, everything has a menu and an entry there. So if I start here to go to settings, so first I'll talk about the settings and a little bit of configuration here. Go to the settings. Here you'll have version control, and here a Git, GitHub, GitLab. Okay, so Git, and there are some specific settings. Okay, so here Git is installed here, and that is running. I mean, that's executable for Git. So many other settings here. You don't have to know everything on this. Okay. I mean, in fact, you need not bother about this setting, but Git here is all about local desktop, and GitHub is remote. So for remote, you have to add, I said you should have an account in GitHub. So that's what I have done here. So you add how you log in, and then that account you have to point out. So here it is logging me in. Initially, you authorize PyCharm people, the JetBrains ID, to connect to that repository. So you have to click authorize to GitHub, and then it will take you to log into GitHub. So I'll show you GitHub one moment. Maybe you've not seen that. So once I configured to log into my account and I authorized PyCharm to log in, it is allowing you to log into the remote repository. Okay. Is that clear, Sriram? Sriram, are you able to follow?
Yeah.
So here is GitHub. Okay. So I go to the URL github.com. Okay. So when this is my own account, every developer can have an account there. This is an open source product, but it's been taken over by Microsoft, and they're developing capabilities on that. So you typically sign in. So you're given a username, password. Okay, you can create a free username, password, doesn't need anything. You can easily create an account. And when it signs in, here is my screen. This is how this is the icon for GitHub. Okay, so here I have signed. I mean, when you sign in, you can create a repository. So I have created a repository called Marco Polo. Okay, just any name you can give. It will suggest also whatever name you want to give. So here there's a menu, code, issues, pull requests, actions, projects, likewise. Starting here is code. So what I've done is I created a repository before this, and I have a local file here. Okay, sorry, let me cancel this. So I've been given a welcome script, no? This main.py. Okay, it's just having print hi, some code for the sake of showing a single function. And this creates two things. One, I mean, this is a project. So I have a local repository, and then I can have a remote repository. Okay. So remote repository I've named as Marco Polo, correct? And I have pushed from, I mean, local master to remote master. I repeat, I push from the local master to the remote master. So then that file comes here. So it happened some 3 hours ago. So I did this already. So I'm just walking you through. Okay, we will do it later, but I'm just walking you through and doing a site tour sort of approach. So quickly, I'll take you to my repository. So things kept here. Now this is my profile page. It can be seen from public. Okay, so if I put some repository, I have a profile here and I can share my repositories to public. Okay, and it keeps track of, you know, when it was contributed and so on. Okay, so if you so basically all the public repositories, see, it has got about 30 repositories I've shared. Okay, yeah, some of my other program code, everything is there, course code is all there. Put it out to public. Okay, so then if you see, this was created as a totally new repository. So system allows you, once you log in, it will allow you to create a repository and you can put it as public or private and all that. Okay. Now, if you go into that repository, okay, keep in mind, I'm not yet signed in here, but since I put it as public repository, anybody in the world can pull it down. Okay, and start developing. So whatever you want to put it in open source is like contributory. Right? So like this only, a group of developers would have put repositories. So you can pull down and you can build on your local and then send a pull request to them. They will see the changes, they are okay, they will merge it. So this is how you contribute to open source. So this file went, I pushed it to the repository. So here print hi. Okay, the file went initially. Okay, so this is the first thing I did. I created a local. I did a commit to the local. Okay, here is the track of that initial commit, and then I added some things, and further I committed, and then I added some more. I added a new function. I pushed from the initial commit, I pushed to the remote master. So here came remote origin master. So it moved from the local master to a remote master. Okay. So I give you a short break here, Sriram, because it should not be a too long haul for you. So I will park this walkthrough at this where it is. We'll meet in about 5-10 minutes. You take a short break. Okay. Is that fine?
Yes, that's fine.
Yeah, that will help you because we'll come back and we'll continue. I'll continue the tour. Okay. Basically, we just done the walkthrough or site tour or walkthrough about what a local repository is, and I showed you GitHub and then a remote repository. You can push from there to here. We have more things. This Git and GitHub are even having certain level of things which you just heard from me, which we can do here. We will do that. Okay. Okay. So I was talking about there's a local uh, repository, and when you commit, that's named master. And when you push it to the remote repository, it's remote origin master. Okay, origin master is just the remote repository location. Okay, or that remote repository is here. Okay, I created a Marco Polo as the repository in my GitHub account, and the code, when we push to the remote, will come here. Okay, this particular lines of file initially It was only having this file. I mean, these lines of code. Okay, then I added something. So I'll come to that shortly. So for now, there is a local repository. You add main to the local repository and then you commit. Okay. Now, where can we see all this? So I showed you a project navigator, which is a standard screen. Again, code editor is standard screen. Git is showing a panel below to show what happened here, give some tracking. But when you have to see, and to recap, of course, we did the settings. We go to settings and we can see GitHub settings here. GitHub is pointed to my account likewise. Okay. So, I mean, nothing in particular. It I'm just showing you where things you can find. And yeah, these settings are there. Now, for a project, it writes file to the local repository pointed here, but you cannot visually read that file. Okay. So definitely it's writing to the local, okay, for the local repository. And that's where it is showing this. Okay, when it shows local and remote, this is local and that is remote. Okay, and this has been the track of changes so far. Now, specific to a file, you might ask, where is what is all the changes to that file? How do I see this showing at a repository level? You right click main, and one among the files here shows show history. Okay, so when I go to show history, it's going to take me to a menu. Everything I did is shown here. So yeah, you're seeing a local history screen which popped up right there. And yeah, you have that screen like that. It shows a complete tracking of all the changes, what happened, when it happened. And here is when I added this file. Initially, the file is in PyCharm. Then it is put to the local repository here with a commit. Okay, the initial commit is initial commit here. Okay, at that timestamp. And then some more changes had happened. I added another function here. So added keys. I'll tell you what happened here. So for now, some changes were committed. Okay. And then further changes, I added a new function at this timestamp. And further changes, I modified that function. And then I had done a branch and then I merged. Okay. So these things happened here. Now you can see on the right side, there are two files here. At the point when I merged, okay, at this point, okay, when I merged, it shows relatively, here is the old file and here is the new file. So there's a side-by-side viewer here. It shows one difference. What's the difference you're seeing? The line numbers on the file on the left, it's the same file. It's one single file. All the changes is in one single file called main. We right clicked here and we went to main. A detailed tracking is on the left pane. On the center, you have the screen divided into two files. Why? Because at this merge, this was the file before, the initial, and when it merged, this was the current file. See, before, that was it, and current is having these two new lines. Do you see that in green? Okay, so that is the difference. So it's showing one difference. Okay, so this way you can see the side-by-side differences, okay, of what it is. Now, so you see this is coming from when you right click, go to local history and show history. You come back once again. Okay. Hope you are getting what I'm saying. Okay. Is are we good so far, Sriram?
Yes.
Okay. So, so in the first stage, what we've done is we just had this welcome script main.py and we checked in, or we put it to the local. We committed to the local, committed that file to the local repository and then the remote repository. Okay, we pushed it to the remote repository. That's all what happened so far. Next task you can say is, okay, I got, if you are, you need a log of that, what happened. I've recorded it here. Okay, so that's this one. Okay, task one, create a local repository and save changes. Next, create a remote repository. So we have step by step all that. Okay, create a project with a welcome script and all that. We'll go step by step on this, but this is what we just walked through. Okay, where we commit the local file, it turns gray, and then you logged into the remote repository called Marco Polo, a remote GitHub account, created a repository, push this local origin master to remote. Okay. So that was task one. Okay, so to go step by step. Yeah. In task two, sometimes we might have an application which has certain file which you don't want to share in public. Okay. So here is an example called secret.py. I just got some secret access keys here. Okay. So think of it like some your own API key or some access key. Okay, I just given a dummy value. And this file should not go to my local and remote. I don't want it to be added. So what to do? Okay, if you go to my main, uh, there is nothing has changed here, but if you see, I might have imported that file here, some line of code to show that this secret is used from secret import access key. That means you know from Python, another file you have to get into this current Python code, you have to use from that file name, import whatever the access, the property or a function is. Okay. So that's simply a change I did on the main.py. So now the file got changed and I have to commit both the files into the repository, but I don't want Git to take this file. So then what we call is ignore, Git ignore. So here is under this V and V, one file called Git ignore. It is typically having a lot of entries, but not to bother about that. The point I want to make here is if I put secret.py into this git ignore file and then do a check-in to the repository, then commit to the local, this file will not be sent into the local. Okay. Whereas my main itself got modified by adding this line of code, right? So that goes into local. Okay, so that's why here you will see that added keys. Okay, again, I'm not taking step by step to show how it is done. I'm just doing a walkthrough only. Okay, so post adding this and checking in or committing this file, this traceability is coming. Added keys. So Git is keeping track of my local changes. Okay. Then, so that's my next task. Ignore a file when you commit. Okay. Add secret, include the secret, this line on the main.py and commit push master origin. So it commits here. So task 2, are you understanding what we are doing there? Okay. So in task 3, the next stage and the final stage here, we take a scenario of where there is a master remote and we create a branch. Okay. We have a master and now we'll branch out to call it like the bug fix. No, this one is called development. It's a application developer who wants to do some build his own feature. So you're branching out to development. So what happens here is that local has a development. So this is the branching. Okay. The branching what we saw is this, and how you will see that is here is the top, the project. Currently the top is on the master. Okay. The last active repository is shown with this, okay, master. So it's on master. I can switch to development. I can keep the latest. So these icons have a meaning. Star means the last active repository. And this card is a current active one. Okay, this star. Okay, the card here. So then, meaning I have a branch and I have a master here. You can switch that here by doing a checkout here. Okay. So there are other commands. We will come to it, but for now, how about doing that branch? How we go about our steps there, which I got it here. Okay. But I'm telling that in the walkthrough or in the site tour, I'm showing that here is a master, here is development. Okay, there are two separate, they are not the same. The file has been branched out to development, and you can see that here. Okay, so I added a new function in that development. I created and added a new function. So this would be the activity. Simple, I mean, doesn't matter what we're doing, but we added function returning a plus b initially, and then I checked in, then I committed. So added new function add, and then I committed.
Okay.
So in the last part, I've added a new function which was like add a b return. Initially I put a plus b. Okay, so that was a modification on the main.py. So when you modify, this is shown by adding a new function. And then I saved the change. Okay, I committed to the local repository, I mean, to the development repository. Okay, to the development branch. What it's called is, we have branched with the name development. We can give any name, no problem. So in that branch, this new function was committed and that got added. Later, I went and modified to that function also, return A plus B it was, but I changed to return A minus B. So it kept track. So this file is modified. I mean, when you commit it, you can give some narrative text like that. So that's what these texts are written. Okay. And it got saved. So, I mean, when you commit, okay, so then all that is there in this show history. See, added new function and then changed and again committed. So modified to A minus B. Okay. And then what I've done finally is so this all these changes done by you can think of it like the feature in development. Okay, you are working on that feature one, you are improving or enhancing that feature one itself with new functionality. And then at point of time I've completed, I want to merge from this development branch to the master or the main branch. So that's, if I go to this, to do that, I do a git checkout on the master and then I do a merge. Okay. So in the merge, and it shows like from the earlier version, what was the change? Here is the change. So this is how it works. Okay. So a complete history is tracked by the version control system. Okay. So yeah, like I just left it here, branch out to development, make changes and merge to the master. So here created development branch, commit, add a function, okay, called add. The changes remain in the development branch. Then I commit in the development branch. So this is saying where I added function. After I commit in the development, I have gone and modified at some point later to modify that function to make a slight change. It was A plus B, I made it to A minus B in that main.py. Okay, so at that time, the file has some color change to blue. So this change, you update, you commit in the development branch and then you update to the master. To update the master, you have to do a checkout of the master and then merge it into the master. Finally, that changes in this master is pushed to the remote. Okay, and when you push to the remote, that's when these changes are now showing up here in the remote repository. These are the changes of a single code. We are just showing a single code. So this is a simple example. Okay. I can do other things out here. See, like the pull requests, what you see here. So we are only with the code. Okay. So the branches and all that. This is the remote repository. Remote repository as the main, the master only. Okay. Whereas the development branch is not in the remote repository. The branch is in the local, and we merged here to the local master and then done a push. Hope you are getting a fair high level on what's happening here. Are able to follow so far? I've just put it into tasks here. We'll be doing step by step also. Okay. Anything, any questions? Okay. So if you don't have any questions, we will go ahead step by step and you can also try. Okay. You want to do that parallelly? So I mean, did you get a hang of it? Is it, how does it appear? Is it too complex or are you able to see in real development, these things happen? And one more thing I want to show it to you because it's a part of the configuration. If I go to settings, we were looking at these two entries under version control. It comes like this. Okay, here is where your interpreter is, project interpreter, project and the project Git Pro 02. In version control, we have this Git, GitHub, GitLab. Okay, so I added the account here, and for you to do so, you also will have to create a GitHub account. Okay, then Git here. But if you see one more thing which I wanted to show, the reason I came here now is like file status, colors. So there are various statuses and different colors. Okay, when you add a file, it is going to show up this main.py in one color. If you had noticed, the color keeps changing. When you add something newly, it is one color. Okay, here it is shown green. Okay, and if it is not going to be taken through, or if it's some ignore status, it's showing this color, secret.py is in orange. Okay, and when something gets later I made a change to the function a plus b to a minus b, it is modified. So it is the modified file is in blue color like this, indicating that one has to change that. One has to indicating that the file is modified or changed. Now you have to commit it to the repository like that. Okay. So when you merge it, finally it shows this color. Okay. And it is ignored, it shows a dark color. Okay. So some color codes are there, but as you work, you will find out it's like yellow and all that. Okay. So it will indicate all that. Okay. So, are you having PyCharm at your end? Have you installed PyCharm? We can try. Can we try now, or would you?
I have Python installed, yes.
Okay. Do you have some time now, or do you want to continue?
I may have to leave in maybe 15,
So
20
then what
minutes.
we'll do is, no problem. I don't want it to land in one single session. We'll do this hands-on, step by step in tomorrow's session. Okay?
All right.
So, are you there tomorrow available at 9?
Yeah, same time tomorrow. Yes,
Same
yes.
time? Okay, we'll do that way. Okay, so that once you do the hands-on, you have a fair understanding now, but when you try it and do it, you will be able to, uh, have a grip on it. Okay. Okay.
All right.
Okay, Sriram. Yeah, you have a good day.
Yes. Yeah.
We'll meet the same time tomorrow. Okay.
All right.
Yeah.
Have a good day.
Yeah. Thank you, Sriram. Bye. Bye.